Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the continuation of the previous video, which is which describes the robot anatomy or a overview of the robot subsystems. So what are the subsystems we have in the entire robot, and what are the applications it is used for? Okay. In this video, the next we are going to see about actuators or drivers. What is actuators or drivers? Actuators are the muscles of the manipulators. What does the manipulator contain? It contains body, arm and a wrist. These three parts are combined together is called as manipulator. This actuator will be acting as a muscle to the three parts. Okay. Actuator provides the movement of body, arm and a wrist. As I told you already, the actuator will provide movement for these manipulators, that is body, arm and a wrist. Actuators determines the speed of operation, load carrying capacity and dynamic performance of the robot. We have different kinds of actuators also. We can see detailedly in upcoming videos. Here the actuators specifically determines the speed of the operation, how speed the robot works, the load carrying capacity, how heavy the load is, and the dynamic performance of the robot, how the robots performed. The actuator will determine the speed of the operation, how speed the robot works, and the load carrying capacity, how much weight it carries. And the third one is the dynamic performance of the robot. Okay. The nature of the application for which the robot can be used is decided by the driver system to some extent. The driver system is nothing but the actuator system, which specifically helps the robots to work effectively and dynamically to the application which is designed for. Okay. Common types of actuators are stepper motors, servo motors, pneumatic cylinders and hydraulic cylinders. These are the common types of actuators. Stepper motors, we know that how does a stepper motors plays a vital role in the robotics. Okay. And even though the pneumatic cylinders and hydraulic cylinders also. What does the pneumatic cylinders and hydraulic cylinders means? Pneumatic cylinders are generally it works by the air pressure. Okay, by the air pressures, the operation it performs its specific operations. Whereas this hydraulic actuators, this performs by using the oil pressure or a water pressure. Okay, by using oil or water pressure, this hydraulic cylinders works. According to their working procedure, the robotic starts working. And here pneumatic cylinders, according to the air pressure, the application differs. These are the another type of actuators, other type of robot autonomy, which is actuators or drivers. We have another type called controller. Why does the controller is used? The controller is used to control the motion of the actuators. Okay, the controller controls the motion of the actuators. The controller acts on data it receiving from the computer and coordinates the motion with the sensory feedback informations. The controller acts on the data it receives and then receives from the computer and coordinates with the motion with the sensory feedback information. The sensors will be incorporated with the robot wrist or an actuator. Wrist or in the complete actuators. So if the information, the coordinate motion, the motion of the actuators will be incorporated by using the controllers which is placed in the computers. Okay, computers, and by using that the complete feedback this motion information will be feedback to the controller, and the controller will have a control of the computer will have the control of the computer. So this will be a feedback motion, so we can understand or we can analyze what the complete motion of the complete application of the robot may be. Okay, the velocity and force velocity and force exerted by the robots are also controlled by the controller. How velocity the robot is and how much force the robot is how much force the robot is producing, and how it works quickly to the time limit. So this can be identified by the controller this can also be controlled by the controller. For example, let us assume that the robot must pick an object for which the joint should be at an angle of 30 degree. For identifying or to control the velocity or a force which is exerted by the robot. Okay, see, we'll have a robot which has to pick an object which is just where the joint, the wrist, that should be in an angle of 30 degree. Okay, if the joint is already not in that angle, then the controller will send a signal to the actuator causing the joint to move. Okay, the controller will send an information to the actuator to make the joint in a correct angle. So okay, these are the use of controllers which is present in the robot anatomy. Thank you.